during the day we got some rain there, so you guys ought to be seeing some here the next day or two, probably.
We're actually on 27 dot. Actually, what the hell are we on? Channel 10. I gotta check the channel chart I made for this customer. The hell do we got here? Yeah, that's 27.555. So that's actually what we're listening to right there.
Or the QSL, their cars either one anymore. We just kind of do the old modulating on the radio. So yeah, we won't do the email or QSL cards there.
I think that's about the only thing going on in upper channels at the moment. So let's get back to the regular channels.
Tell you what, you're sounding like regular DX for sure. I think you can hit me always earlier, but
there's 38.
Coming in here at about 5 to 7 over. Sounds good. Double link. Buckeye, WB 911 out of Michigan. Buckeye 73, WB 911 Michigan, standing by.
So I'm going to guess the AM channels down on the Jabberjaw channels are probably jumping. Yeah, that's the Never Makes Any Sense channel, which is number 6. Whew, channel 20's jumping today.
Triple four. I'm gonna use this thing back. I'm definitely thinking about
28.
I know he's out there probably talking some smack right about now.
And did I just hear somebody call Breaker 19 on channel 28? Yeah, there's somebody calling for local information on channel 28. Yeah, I think he's on the... He doesn't know what channel his radio's on. So, in any case, what we have here today is a rather rare... this is a DAK VI SSB. So, probably the best comparison for this is the DAK 10. Because that's basically what it is. It's the DAK 10 chassis. So if you open up one of those hybrid DAK 10s, same circuit board, missing all of the driver and final section because they have a vacuum tube driver and final. This one is 100% solid state. It's a mobile. So if you ever look in the DAK 10, you're going to notice that this heatsink, all of the components, everything in this area is missing. Pretty much everything else, though, in here is the same. There are a few other minor variations because that one has the tube driver final section, and then there's a metering board that sits in the back. But otherwise, the rest of the chassis is pretty much the same. And what it is a poor man's or cheap copy of a Cybernet. It's, yeah, they weren't the greatest boards. Or, you know, I've never been a DAK fan. Now, when a DAK works, it works great. Because when it works right, it's working as good as the Cybernet. But the problem is just the DAK's just poor quality. Not the... Like I say, it's a poor man's copy of a Cybernet chassis, and they didn't do a great job at it. cybernets have, but it's not just a cybernet problem. All manufacturers at some point through their history have used double-sided circuit boards. And if they did, the early double-sided circuit boards, they all had the problem of the pass-through solder connections failing. But these are just even worse. I don't know why. These boards, the only thing I can figure is just the poorer board quality. They expand and contract even more than most of the other boards. So they tend to break out even more. This one was a good working radio now. It worked before, but the customer wanted to recap, so all the electrolytic capacitors have been replaced, the nasty glue's been removed out of it. As you can see, there's a little switch box over here, and yeah, the label's upside down. It's because the radio's upside down. Now, when you flip the radio over, the box will be right side up. Did make up a channel chart for them, so there's the 1 through 40 is on this. And when I did this, this actually had a previous channel modification that was removed, and I wired this one up for him. And the way I've got this one is, usually when you do switch mods, you get a little chunk of channels here, and then something else over here, and yeah, it's just, and the channel charts are a nightmare to try and keep up with. I tried to keep this one fairly in order, so this basically goes straight through. It starts off at 27.445, and then from channel 1 up to channel 40, it just is an ever-increasing in frequency range. And there's 3 blocks at which he'll have to change the switch positions. There are 3 position switches from center to down. There's up here somewhere. There's, to up. But like I say, you can see in these switch positions, it's good up to channel 13, and then from channel 14 to 27 is another block, and then from 28 to 40 is another block of channels that are in order. And then there's even some more channels over here from channel 1 to 18. 18 is a little iffy. The VCO can only lock on so many frequencies. And this radio is capable of, well, the PLL is capable of 511 channels. The problem is the VCO is never going to lock on all those frequencies. You'll never get 5.11 megahertz worth of range out of a radio like this. This is stretching it right here. Right now, the way I have it, it just locks on channel 1, or well, not this channel 1, CB channel 1, and then can go up to this channel. And this one, yeah, it's right borderline VCO voltage-wise for it to lock. But he wanted a channel chart, so I made this up for him and laminated it. So there's the insides. Like I say, it's basically, if you've ever seen the insides of a DAK 10, that's basically what you're looking at. Like I say, with the exception of this over here, everything else pretty much in here is the same. And this, as you can hear, it's a good receiving radio. Receive sensitivity definitely did pick up on this. These are rare, really rare. They're rarer than the DAK 10s, actually. If you ever get one of these, do yourself a favor. Be really, really, really careful if you do an alignment on it. You actually grab the correct tool for doing this. So there are 2 cores in here. Now, being a Cybernet clone, it has a Cybernet style VCO can. Again, it's a clone, so it's not exactly the same. But usually the Cybernets have a hollow core in the tuning coil down here in the transformer, and it's a square hole and they crack really, really easily. This doesn't have that. This has the normal cores like most of your normal transformers have. However, if you get over to the RF section here, this transformer right here and this transformer right here, if I can zoom in close enough that you can see it there, you can see how they have a little square hole in them. Those cores are extremely fragile. If you try to use, trust me, don't try it because you'll break them. If you try to use anything but the correct tool to adjust those, you are going to break them. Guaranteed. There is only one tool on the face of the planet designed to do those, and that's a proper alignment tool. And it's actually square, okay? If you use anything but one of these, you're going to break them. And this is still available. Actually, it's the number on here, I can barely make it out. Actually, I got a whole bag full of them. Just grabbed a bag of them. And I'll get a brand new one out here. one of those things I stocked up on a long time ago. GC Electronics still makes them. Yeah, it's a GC 9440 is what they are. And there's a nice shiny brand new one, never been used. And then it also has the tip, because usually most alignment tools have multiple tools built in, you know, at different levels. But this has a really small screwdriver style actually on the tip of that one. But that's the tool to use for those. If you don't use this, guaranteed you're going to break it. Just spend the $1 and whatever it costs for these alignment tool, you know, from GC Electronics. I got a couple dozen of them for fear that at some point they'll probably stop making them. So, you know, I've got a lifetime supply. But, yeah, other than that, there's really no other idiosyncrasies other than if you have one of these things and you're having intermittent problems, I can pretty much guarantee you if it's an intermittent, it's a bad solder joint. And it's at one of those pass-throughs somewhere in the radio. It's going to depend on what problem you're having exactly. But, yeah, just look for any of these little blobs of solder that are on the top side of the board. That's usually where the fault's going to be. It is rarely, if ever, a bad solder joint on the bottom side of the board. It's usually on the top side is where the solder joints fail. There's a whole row of them along the front here, and then they're just scattered all over the circuit board. So, that's about it. Let me get the covers put back on this thing so you can see it all put back together. Get her flipped over and just do a little bit more listening here. And so, give me a second. I'll be back.
Yeah, okie dokie there, 429. You have a good one as well. We'll catch you another time. Old timer 669. For Illinois, we'll be standing by. Protect your pipe and smoke it, Sean.
You ever notice how when I get a radio completely put back together, the skip just vanishes?
Holy moly. CKDX 100 Southeast Missouri, we're trying.
There's still some. But I swear, if you want Skip to come in, have me get the covers off the radio. I put the covers back on and it all goes away. Sounds like 39's busy. Oh, one thing I forgot to mention before and almost forgot again. Originally this radio it was more than a quarter of them out. I think it was, God, probably like a third of the segments in the displays were completely out. It actually wasn't anything wrong with the display. It was the dropping resistor networks. So what these radios use, much like a lot of other radios, so this isn't just a DAK thing, they use what's called a resistor network, okay? So each one of these is actually 7 individual resistors. You can get these things wired differently and with different numbers of pins, but what these are 7 resistors, basically, you know, straight across. So from this pin to this pin's one resistor, and then you go over one, that'll be another resistor, as I drop that one on the floor. But the problem with these early ones is they disintegrate. They just literally, you can see the pins are missing off of this one. As I was desoldering it, the pins were just falling off. But they were like a ceramic substrates, kind of what they look like. I guess they printed the resistive material on top, put the leads on it, and put like an epoxy over the top. But yeah, over the decades, these things just they don't hold up too well. And honestly, I just don't like them. And especially in this radio, these things were hot. I mean, really hot. They're 1.5K resistors. So what I had actually installed into this are individual leaded resistors. So I've put 14 regular resistors in this. Now even those are getting hot, but they're not as hot as this one individual package, because now all those resistors just add up to have a lot more surface area so they can cool off more efficiently. But even those were still running a little bit too hot for my comfort. In my opinion, they were just pumping a little bit too much current through those LEDs here. So I actually added, the way the channel selector switch and the display works in this is they supply voltage to the channel selector switch, to the segment select section of the channel selector switch. That then applies voltage to whichever display element they want to light up. it comes out, or goes then through this, so I dropped that one on the floor too, goes through the resistor network and then to ground, to a common ground type, or is it, do I got that backwards? I always have to, I actually had to look at, because there is no schematic for this. I'm trying to think, how was that wired? Did they have it the other way around? It was the voltage source. Yeah, I think it was the voltage source to the board, to the channel selector, up through the resistor network, to the display, and then down to the common ground. I think these had the commons tied to ground. But anyhow, like I said, I've put individual resistors in there. That just gives it a lot more surface area, but they still were just, in my opinion, pumping way too much current through this display. Those resistors were just way too hot. The display was really bright. So I added a little bit of additional resistance in series with the voltage supply line to the channel selector switch. So I've lowered it a little bit more. The display is just slightly dimmer, but still looks just fine. And now those resistors aren't boiling hot. That big 1 watt resistor that I stuck in there is just barely lukewarm. And now that whole row of 14 resistors in there is just now barely lukewarm too. It's kind of just spread the heat dissipation out a little bit. But yeah, it worked out a lot better that way.
Here to Dallas, Texas today, 321 with a wave. 105. Illinois, where? Springfield, Illinois.
Sounds like all the I states are coming in. Iowa, Illinois. I had to drive through all of them before. My God, is that ever about the most boring ride on the planet. Flat country, man. There's just nothing to look at.
You're making a great trip, so keep up the good work, Roger. All right, Tom, you do good. Good luck with Oh, Mr. Brown, shoes. I'll train you bye.
Yeah. What else would you expect to hear on 6? Bye, bye, bye. That's the only word they know. Jesus, that guy's bleeding. He's just bleeding channels. And actually, sounds like AM skip's starting to fade out a little bit. God, guy, turn your echo down. Somebody might actually be able to understand what you're saying. People on their blasted noise.
Next blanket in New Jersey. Nationwide good news. Big old quad on the sun power is getting down. What kind of week do you think of?
So, in any case, like I say, I thought I'd show this one because it is really rare. You really don't see many of these. There are way more DAK 10s out there, I think, than there are more the DAK 6s. Actually, I haven't really gone over it. The control complement on these is pretty standard. Mic gain volume on off, squelch, SWR, RF gain, clarifier. It's got a signal meter, function switch, CBPA. One thing I do like about this radio is it does have the noise filter, or the high frequency filter, I should say. So
enjoy the weekend here. We're back live.
which I much prefer the high filter on. Filters out all the high frequency stuff, which is where most of your noise is. And actually, if we find a channel with not much on it, well, actually right now, right there, you can hear how much that cuts the noise out. Because that's where most of your sizzling bacon is, high frequency. Oop, CBPA, wrong switch. Now this does have an ANL noise blanker. I don't really like the noise blank or the ANL functioning, how it works in this radio. I think it cuts out too much of the low. Personally, I think turning the high frequency cut on actually is the best option. But and then AM upper lower sideband. So there you go. There it is with the covers back on it. Yes, it had 2 holes bodged in the top of it, and actually there's another set of holes in the bottom. I've installed plugs in those to seal off the holes. Try and clean the cosmetics up on it a little bit. You know, what can you do? The hole's a hole. Short of TIG welding it shut and completely refinishing the covers, that's a lot of work just to fill in 2 holes. So yeah, let's put some nice low profile plugs in there and makes it look a lot better. And then for the little switch box here, what I'll do is I always supply a piece of double-sided, Velcro tape, so you can stick the box on the underside, stick it on the top, set it on a desk, because I'm sure it's going to be used as a base station. I know this customer will probably keep this indoors, so he can just set the box beside it, do whatever he wants with it. But yeah, I hate it when people drill holes and stuff. You must drill a hole in a radio, for God's sakes, drill it in the back. Don't drill it in the covers. I just feel like grabbing the drills out of people's hands and running it through the side of their skull before they butcher radios, because that just kills me, man. And even worse is when you see people drill holes in the front of a radio. Well, that drives me nuts. So, in any case, DAK 6. Actually, I guess it's not a Mark 6. It's just a DAK 6 SSB. 40 channel. Well, actually, it's now a 80, 90. It's a 98 channel radio now. So there you go.